identifying linear and nonlinear equations. And you need to know some little properties before. Linear moves at what's called a constant rate.
Oh, I knew that.
Constant means that it's always the same steepness throughout. There's no breaks, it doesn't shift speed, it's going constantly. It's like traveling down a highway at 65 miles an hour and never having to slow down. You know, you're just constant rate. And it is a straight line. So linear is constant and it's a straight line. And it always looks like this equation. Y is equal to something times x plus something. This is actually slope-intercept. We're going to be dealing with this tons next chapter. And it's the heart of 8th grade standards. Knowing this equation by heart is going to help you tremendously. Y is equal to mx plus b. This m is really our rate. It's how fast something is changing. We call it slope in math. You'll learn about that more. And this is just, you'll learn that later. Nonlinear doesn't move at a constant rate. It is not a straight line. So linear is constant, nonlinear, nope, it's not. And here's some examples. Linear, straight line, and I don't care where you draw it, just draw some examples. Linear, ooh, it can decrease constantly too, straight line. Hey, guess what else it can do? It can be just a horizontal straight line or a vertical straight line. Anything that's straight is linear. And it doesn't matter the steepness. Linear is anything straight. Nonlinear, that's called a parabola. Did you know
That's
that?
a big
It's
word.
parabola. That's a parabola, it's nonlinear. Do you see? Because it looks like a U. You want to know what else is then? A quadratic.
A V.
That is a quadratic, looking like a little snake scooting up through the coordinate plane. That is nonlinear. You want to know what else is nonlinear? An exponential function. When it grows really fast, exponential means fast, or it gets big really fast. So, you want to know what else is nonlinear? A normal line that all of a sudden will shift.
Neat.
That's nonlinear because it has to be constant change. And here I was constantly increasing, and then all of a sudden I constantly decrease. Nope, can't happen. All right, so if you're given a graph, do you feel like you can identify if it's linear or nonlinear? Yep, me too. I feel pretty good about that. Okay. So the next part of your learning target, it's still part of identifying linear and nonlinear equations. It's still part of that. But now you're going to be given tables. So you're going to be given a table of values today, and you got to identify if that table is linear or not. It's easy to, there's a trick. You can either graph them or apply the trick. So linear is when you add or subtract the same thing. Okay? It's same thing to x and y. I mean, they don't have to be the same thing, meaning like I could add 2 to x and add 1 to y, but as long as x is always plus 2 and as long as y is always plus 1, it's linear. Nonlinear is when you multiply or divide by the same thing, because remember, that's when it gets bigger faster. That's an exponential thing, you know? Or not a pattern. If there's not a pattern, it is not linear. All right, let's apply this. So linear, add or subtract the same thing to x and y. Nonlinear, multiply or divide. So, here we go. What did I do to 9 to get to 11?
And 2.
Add 2. What did I do to 11 to get to 13?
Add 2.
Okay, what did I do to 13?
Add 2.
All right, so that's constant. Now let me make sure that the x is constant. What did I do to 4 to get to 5?
Add 1.
plus 1. What did I do to 5 to get to 6?
That's one.
6 to 7?
That's one.
So I'm adding or subtracting the same thing to the x and y. It doesn't have to be the same number as long as the x is always the same thing and the y is always the same thing. This is linear. And if you were to graph those on a coordinate plane and connect the dots, it would look like a straight line. All right, and then we do the x and y on this next table. What did I do to, I usually always check my y first. What did I do to 9 to get to 12? Plus 3. 12 to 15? Plus 3. 15 to 18? Plus 3. Okay, that looks good. Now let me check to make sure that my x change is constant. 8 to 10, 2. 10 to 12, 2. 12 to 14, 2. That's a constant adding, so this is linear. Okay, next one, what did I do to 4 to get to 9? I added 5. What did I do to 9 to get to 16? Added 7. Already I can tell nonlinear. I don't even have to do anything else. I already got a different pattern. It's not linear. I only fully check it if it does change by constant number. Okay. So the next one, doesn't matter where you start. I'm just used to starting with y because slope is defined with y. And so I'm really used to working with slope. What did I do to 0 to get to -1? Subtracted 1. What did I do to -1 to get to 0? I added 1. This is nonlinear. Because I didn't add or subtract the same thing. And the last one. 12 to 13 plus 1 plus 1 plus 1. Looks good. 4 to 5 plus 1 plus 1 plus 1. This would be linear. Now that's the quick way to do this. Being able to define it by checking just the patterns. The patterns will always tell you if it's the same thing, it will always tell you. However, another thing you need to know how to do is identify from a graph. So we did that in the front page. You're going to be given a table of values today, and you're going to be expected to graph them and identify if they are linear or not. So I'm going to just show you with a couple of these. These are my x and y's. Remember, every point on a graph is consisted of an x and a y. So each one of these are a point. 4, 9, 5, 11, 6, 13, 7, 15. Those are all consisted of points. The tricky part is going to have to be the scale. How are you going to scale it? Because you're going to get weird numbers. This only goes to 10. So you're going to have to scale it by something different in order to get to that 15. I'll scale by 2. Okay. So, and then my x's I'm still going to scale by 1. My y's I'm going to scale by 2. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18. That will be 20. And you should be used to doing this with your science fair project. Scaling and seeing how to create your line and table. All right, so I have x is 4, y is 9. So 1, 2, 3, 4, and then go to the 9 for the y. 2, 4, 6, 8, 9. And then 5, 11. 2, 4, 6, 8, 10, 11's in between. It's hard for me because my screen's not that orientated. 6 to 13. 2, wait, what's this? 6 to 13, 2, 4, 6, 8, 10, 12, 13's right here. As you can see, you should be able to see that it's looking like a line, but don't just guess. You have to make sure to plot every point before you just assume that it's a line. 7 and 15. 1, 2, 3, 4, 5, 6, 7. 2, 4, 6, 8, 10, 12, 14, 15. And yes, this looks like a straight line, so this would be linear. And that's pretty much what you'll always do for all of them. I'll do a nonlinear example so you can see that. Hey, this one looks nice and easy because my values aren't bad at all. Okay, so again, remember, a point is the x comma y. You have to put x first. So these are my points, -1, 0, 0, -1, 1, 0, 2, 3, x, y. So this is -1, 0, 0, -1, 1, 0, 2, 3. Maybe that'll help you to put it in that format when you graph. And then I don't have to scale this by anything because they're all nice numbers. So -1 and 0 would be right here. 0, -1 right here. And this is why you don't just assume, because this looks like a straight line to me. But now I go 1 to 0. No, that's not a straight line, because I didn't, a straight line would go down. Now I scoot it up, that's nonlinear. And then 2, 3, 1, 2, 1, 2, 3. So this looks like a check mark. That is non-linear. So just to summarize, we're done for today. Your learning target was to be able to identify learning or linear and nonlinear. Linear is a constant change. Nonlinear changes its speed or direction.